All right, so we're going to be working on prime factorization. This is our sixth grade standard of which is a process breaking down a number into only prime factors. So our last video talked about what a prime number and a composite number was. And we can take any composite number and break it into only its prime factors. So remember, our sixth grade prime factors that we really need to worry about is 2, 3, 5, 7, 11, 13, sometimes 17, sometimes 19. But for the most part, these six numbers are going to be your friends for prime factorization in sixth grade. There are two ways to find it, using the tree method and using the cake or slide method. So I'm going to be showing you both ways. I'm going to be doing about 3 or 4 examples so I can show you how to break numbers down, decompose them into only their prime factors. All right, so our first example is going to be 45, which my son gave me that number to do. And so we're going to be breaking 45 down both ways. First way is going to be the tree method, and the other way is going to be the cake or slide method. So if I'm going ahead and breaking 45 down, what I need to do is I need to think of my multiplication facts and think of what numbers I can break 45 into. So 45, and again, this is the tree method. You'll see why it's called the tree method. I can either do 3 times 15 or I can do 5 times 9. Most sixth graders are most familiar with 5 times 9 because that's a multiplication fact that we generally learn. So if I break 45, I want to do 5 times 9. Okay, since I want to break it down only to my prime numbers, I know 5 is prime. So I'm going to go ahead and circle 5. That branch of my tree is done. Now I can take 9 and break it apart to 3 times 3. Because 3 times 3 is 9, and 9 times 5 is 45. So the prime factorization of 45 is 3 times 3 times 5. And we're welcome to write that with exponents if we want to. Remember, exponents are a way to write repeated multiplication a little bit more condensed. So 3 times 3 can also be written as 3 to the second power or 3 squared times 5. So if I use my order of operations of 3 to the second power is 9, and 9 times 5 is 45. So that's the prime factorization of 45 with the tree method. The reason I don't like the tree method is if a student has, let's say, the number 20 they're breaking apart, a lot of times students are going to want to do 10 and 10 because they're thinking of dividing it in half. And if they write 10 times 10, 10 times 10 is not 20, it's 100. So that is where the misstep of doing the factor tree for prime factorization is. Okay, so the other method is the cake or slide method. So what I do is, since this is a form of division, because I keep breaking it into division problems, I put 45 in a division bar. And again, I'm looking for my prime numbers. And remember, my prime numbers are 2, 3, 5, 7, 11, 13, and 17. So I know that 5, which is a prime number, goes into 45 9 times. Okay, instead of doing 9 times 5 and subtracting it down here, because I know it goes in evenly, what I do is I keep building up until I only have a prime number up on the top. So I know 9 is a composite number. It is not in my list of factors, which I'm going to go ahead and write down here again. 2, 3, 5, 7, 11, 13. Okay, I know that 3 goes into 9. 9 is not in my list, so I keep going. So 3 times 3 is 9. Since this top 3 is in my list, I stop. And there is my answer right there. So if I take my 5 times 3 times 3, I'm going to get the same answer as I did in my factor tree. Okay? All right, so let's go ahead and do our next example. All right, so we're going to go ahead and do 72. I'm going to go ahead and do the factor tree first, and then I'm going to go ahead and do the slide method. So if I look at 72, okay, again, this one has a lot of different factors. I know 4 goes into it. I know that 6 goes into it. I know that 8 goes into it, 9 goes into it. So there are a lot of numbers that I could start off with. So again, the most frequent one that students know, 72, is 8 times 9. So I'm going to go ahead and break that apart into 8 times 9. So 8 times 9 is 72, okay? 8 and 9 both aren't in my prime number list. So that means I need to keep branching both of them apart until I start getting these prime numbers. So if I look at 8, the only way I can get 8 is 2 times 4. Again, this is where some students take 8 and they break it into 4 and 4 because they're thinking of 8 being split into 2 equal pieces. But 2 equal pieces is 4 because remember we're doing multiplication. And if I go back through my list, 2 times 4 is 8 and 8 times 9 is 72. Okay, 2 is in my prime factor list, so I go ahead and circle the 2. Okay, and then I go ahead and take 4 and I break that apart into 2 prime numbers. I know that 4 is 2 times 2. 2 is in my prime factor list, so I go ahead and circle both of those. So that part of my tree is done. Okay, moving on to 9. The only way that I can multiply and get 9, because remember I only want prime numbers, so I don't do 1 times 9, is 3 times 3. Both 3's are in my prime number list, so I go ahead and circle both of those, and now that is done. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 3 times 3. Again, I can write this with exponents since I have repeated multiplication. I have 3 2's. So this can be written as 2 to the 3rd power because I have 3 2's and I multiply it with my 2 3's. So 2 3 times 3 2 times, and that's what I have there. So I'm welcome to shorten that up. All right. If I'm doing the cake or the slide method, again, since this is a form of division going down, I put 72 in a division box. Okay. And I'm only going to use these numbers. Since 72 is even, I know 2 can go into it evenly. Okay, now the only issue with this is if I don't know how many 2's are in 72, I am going to have to do a little bit of long division. So 2 goes into 7 3 times, and I'm going to have 1 left over, and 2 goes into 12 6 times. Okay, so I am allowed to write that a little bit down there. All right, so 36 goes in evenly. All right, now I'm going to ignore this because now I'm only going to worry about my 36. Again, I can only use 2, 3, 5, 7, 11, and 13. And since 36 is an even number, again, I can divide 2 into 36. Okay, I know that half of 36 is 18. Okay, keeping going, 18 is an even number, so I know 2 goes into it. Or some of you are like, oh, I know 3 goes into it. You can go either way. Let's go with 3, all right? So if I go 3 times 6 is 18. All right, again, I can use 2 or 3 here because at the end, 2 or 3 is going to be here. So if I go with 3 here, 2 will go on top. And again, at the end, I have the 2 times 2 times 2 times 3 times 3. So I still have all the factors that I had down here with doing the tree. So either way, whichever way you're more comfortable with, that's the way you really should do it. I personally like this way only because I feel like there's less error that can happen. And this is going to come in really handy when we do greatest common factor and least common multiple, and when we're rewriting expressions using the distributive property, which is what we're going to be learning here soon. So again, you choose which way works best for you. Either way is correct, and I would use which way works better for you.